I'm Zach, Solutions Architect with StackHawk. Today I'm going to talk about StackHawk's integrations with GitHub. Dynamic Application Security Testing, or DAST, is an active form of security testing that is similar to how a hacker or penetration tester would attack a web application. DAST can test any running app. It's language agnostic. It exposes runtime vulnerabilities, and when tuned correctly, it produces low false positives. But legacy DAST tools are oriented towards infrequent manual testing of production environments. They're notorious for scans that take hours or days to complete. By the time a new vulnerability gets assigned to developers for remediation, the bug is already in production, and developers have moved on from the context of the code that produced it. Legacy DAST solutions don't scale well beyond a handful of applications, and they lack sophisticated methods of application discovery, so they can't deeply scan modern APIs or GraphQL. These tools are designed to be used by application security teams rather than developers, and at most companies, software developers outnumber AppSec engineers 100 to 1. The result of all of this is low-frequency, low-depth scanning with low coverage across apps, long lead times on fixing vulnerabilities, and unpredictable software roadmap delays. StackHawk is disrupting this space by transforming DAST into a fast, automated software quality check that can run on every pull request. StackHawk was designed to enable frequent DAST scanning with developer workflows. It helps developers fix vulnerabilities while they're in the context of the code that produced them, and long before that code reaches production. We do this by being closer to the code, with tools that are easy for developers to configure, run, and automate. And we provide resources that help them understand and fix vulnerabilities quickly. StackHawk is engineered specifically for easy automation in CI/CD, where it quickly and consistently finds runtime vulnerabilities on every PR and every commit. StackHawk has deep coverage for modern APIs, including REST, SOAP, GraphQL, and even gRPC. And our simple configuration and architecture mean you can get your first scan up and running in minutes, with no dedicated infrastructure. StackHawk has built a number of deep integrations into the GitHub ecosystem that help developers get the best, most efficient experience for developing secure code. Our HawkScan action makes it a snap to integrate our scanner, HawkScan, into GitHub Actions workflows. Our pull request check integration gives developers rich scan details right in their PRs, so they seldom need to leave the familiar GitHub interface to stay on top of API security findings. And our CodeQL integration means developers can see code-level insights into the high-priority exploitable security issues surfaced by HawkScan. This combination of integrations makes it easy for developers to adopt StackHawk and GitHub together, and hard to walk away once they've experienced this efficient workflow. Let's look at each in a little more detail. Our GitHub Actions integration is the deepest CI/CD integration we've ever built. It helps to make GitHub Actions one of our most popular CI/CD deployment options. The HawkScan action is listed in the GitHub Actions marketplace with comprehensive documentation, so it's easy to find, configure, and implement. It's a full-featured GitHub action, so it's not just easy to add to workflows, it's flexible enough to handle complex use cases. StackHawk pull request checks create a fast security feedback loop for developers. It's powered by the StackHawk application in the GitHub marketplace. It works by associating PR branch and commit information to every scan that runs in the context of a GitHub PR. It uses that context to post scan results back to the PR as a comment, and update the StackHawk PR check status as well. All of this creates a fast feedback loop so that developers are quickly made aware of new security bugs and given the tools they need to reproduce and fix those bugs before merging the PR. Finally, our CodeQL integration surfaces relevant static analysis findings within the StackHawk Finding Details page. This integration is also powered by the StackHawk app in the GitHub marketplace. StackHawk DAST findings identify runtime vulnerabilities that should be prioritized for fixing, but like other DAST tools, the evidence they produce is in the form of application request and response data. It's great for reproducing and retesting for the existence of a vulnerability, but it can't show you where to find that bug in your code. So on every scan, we consult CodeQL to see if it has SAST findings that correlate to our DAST findings based on their common weakness enumeration, or CWE ID. And if we find a match, we surface CodeQL's code-level insights directly into our finding details. This gives developers precise information on where to start looking to fix security bugs. In all of our customer surveys, users confirm this integration helps resolve bugs quickly. Let's see these integrations in action. To demonstrate our GitHub integrations, I'm going to use Vuln Express, a test application for DAST scanners. In this code repository, you can see I've got some GitHub workflows, and I've got a StackHawk configuration file that defines our HawkScan scanner configuration. Let's take a look at this configuration file. In the Apps section of the configuration, we have an application ID that associates our scan results with the Vuln Express app we defined in the StackHawk platform. By default, scans will be associated with the development environment, but we can change that at scan time by setting the environment variable hawkenv. The target host is set to localhost port 3000, which is where we'll be running the Vuln Express app when we scan it. In the Hawk section, we set failure threshold to high, so that if the scanner finds a new high criticality issue that has not already been triaged, the scan will fail, thus breaking the build pipeline. Finally, in the tags section, we set 2 special tags to associate scan results with a particular git commit hash and branch. The StackHawk GitHub app can then use that context to associate a particular scan to the PR that initiated it in GitHub Actions. Finally, in the tags section, we set 2 special tags to associate scan results with a particular git commit hash and branch. The StackHawk GitHub app can use that context to associate a particular scan to the PR that initiated it in GitHub Actions. Let's go back to the root of the repo and look under GitHub Workflows. And let's take a look at, we've got a CodeQL analysis workflow that's set up to run CodeQL on every pull request. So that'll come in handy when we show you the CodeQL integration. We've also got a HawkScan workflow. And this is a simple workflow that runs on pull requests as well as commits or pushes to the main branch. And it's got a single job with a number of steps. First, notice that we're setting the commit SHA and branch name environment variables, and we're going to pass those through to the scanner so that it can set those tags that we talked about that help associate the scan results with a particular PR. Then this workflow goes through these steps, which are to check out the code, install Node.js, install the dependencies for the Vuln Express test application, run unit tests, and then bring up the application, daemonize it right on the GitHub Actions build runner so that it can be scanned by HawkScan. And then finally, we'll use our HawkScan action to run HawkScan, and it'll scan that Vuln Express application. And once that's complete, it should post its status back to the pull request, if there is a pull request. And it should also post its scan results back to that pull request as a pull request comment. So let's see how that works. I'm going to edit this file and make a minor change, but first I want to change to a new branch. I'm going to call my new branch feature demo. And I'm going to edit this file. And I'm one of those guys who doesn't like to have an empty line at the end of my file. So I'm going to delete that. And I feel like that's worthy of a pull request. So I'm going to commit these changes. And then I'm going to go back here and I'm going to make a pull request. I want to make a pull request back to my fork of this application. And I've just updated hawkscan.yaml. So let's create that pull request and see what happens. We have a couple of checks that we need to pass before we can merge this. And one of those is the code QL run, and the other is our HawkScan workflow. I want to go check this build and scan workflow. So we can see we've set up the job, checked out code, installing Node.js. So this is the HawkScan build and scan workflow. The application is up and running, and now we're beginning to run HawkScan. So the HawkScan action is going to download the HawkScan application, and then it's going to fire up the scanner, and it reads in the StackHawk.yaml configuration file at the base of the repo, and then it prints out a small summary of what it's about to scan, fires up the scan engine, spiders the application, and then starts scanning. And when it's done scanning, it's going to print out a summary of the results of this scan and provide a link back to the scan results in our platform. And I'll go take a look at those in a sec. Just to look at the very end of the HawkScan results, we've also got an over threshold error. So this is that failure threshold that we set in the configuration file for the scanner. And we did cross that threshold. We have one new finding with a severity greater than or equal to high. Okay, we'll take a look at those results in a moment, but I want to jump back to my pull request and show you what we've done here. So here's the pull request, and here's a comment made by the StackHawk bot, which shows us all of the findings. We can actually drill down to vulnerability details, but we can see from this that we've run a scan. HawkScan did complete on the vulnode express application in the GitHub Actions environment, and the check failed because we found one finding that crosses our failure threshold of high severity issues that are new. We've got the vulnerability details, we've got scan metadata, and we've got some scan IDs here. We can jump to StackHawk and view all of the results and all of the details of this scan result in StackHawk. But just to show one more thing, we've also got the StackHawk HawkScan official status check. And this is reporting as failed. And again, this is part of the StackHawk application in the GitHub marketplace. So now we can click through to these details, and that should take us right over to the StackHawk platform where we can look at all of these details. So in this findings scan details page, we're getting a summary of which application we scanned, a scan ID so we can track this in the system, the environment name, GitHub Actions, and the fact that we scanned the local host. We've also got some other metadata here. And up along the top, we've got in bright colors any new vulnerabilities that we found, whether they were high, medium, or low, and also how many triaged issues we've got. So we've got some that are assigned, some that have been risk accepted. And then when we go down below, we can see all of the types of vulnerabilities that we've found, including SQL injection, cross-site scripting, etc. We can see that we've got SAST results that correlate with one of these findings, SQL injection, and that's on this high criticality issue, which is new and has not been triaged, and several of the other findings have been triaged, either by being assigned to tickets or marked as risk accepted. Let's take a look at the SQL injection issue and see what we get from the SAST integration with CodeQL. When I click in here, I've got results that map to a developer's needs. What we want them to see is what this means, what a SQL injection vulnerability is all about. And in this case, we've got some cheat sheets so we can show the developer what this vulnerability looks like in certain types of languages and frameworks, and also what the fix tends to look like. On the right side, we've got our evidence pane where we show typical DAST results, which are the request that the scanner made of the application and the response that we got back. But in this case, because we've got the StackHawk app integrated with GitHub, we can also expose GitHub CodeQL information. And so now we're able to surface this finding from GitHub CodeQL that shows that we've got a match on CWE. They found a CWE89 vulnerability, and so did we. And so we're going to surface the details from that right here in our findings detail page. So now we can see that as a developer, I should go look at my service search.js file to start fixing this bug. And in fact, I should look at line 6 in particular. I can also click through this CodeQL details button to go all the way back to GitHub and see the full narrative around this bug, around this vulnerability warning. And this gives me great context so I can go and fix this issue. That's how StackHawk integrates with GitHub. With the HawkScan action in the GitHub Actions Marketplace and the StackHawk app in the GitHub Applications Marketplace. The combination elevates security testing in the workflows that developers already love.